Recording. Maybe. Okay. Hello again, and welcome to the Azure podcast. I'm your host, Evan Baslick. I'm joined today we're recording episode number 379, and we'll be talking about Azure for Operators with Shawn Hakl. And so I've got my fellow guests or fellow hosts here, Kale, Sajit, Cynthia, and Kendall. And Kale, you want to talk about, I guess it's not really news, but it's more just an awareness thing for everybody.
Yeah, sure. We don't have much news this week because this week build starts. So for those our listeners who might not be aware, build is a pretty large event that we have annually, and usually we have it, on premises, somewhere. It's been in San Francisco in the past, and then it was in Seattle, but it's virtual and it's free. So you can just go register for that. Now it starts on the 25th of May and then runs through the 27th. Depending on when we get this podcast up there, if you got in there late, you can still go look at the on-demand content. So everything's there for you to consume to your heart's content about many, many different products in Azure for developers, infrastructure, all that kind of stuff. So check it out. I'm sure most people already know what build is, but I just want to give a call out for those who may be new to the space.
Yeah, and I wanted to just mention one thing real quick because I was just in there signing up with some of the sessions, and some of them are limited, space limited, even though they are virtual because they're supposed to be interactive sessions. They don't want 2,000 people in the same session or something. So you get in there early especially if you want to get into some of those sessions with the engineering teams, for example.
Great. Yeah, and although I wish I could say we were coordinated enough to plan this, but we actually had two big announcements in the Azure for Operators space today, or recently. One being a partnership between Microsoft and Amdocs, basically bringing Azure into the ecosystem, for the vendors, and then Telefonica, which is merging their, Azure's edge zones and AI and ML capabilities with Telefonica's private 5G networks for like manufacturing scenarios, right? Typical networking doesn't work in those worlds. And I guess, that's a great transition into Shawn. Shawn, tell us who you are and what you do for Microsoft and what this Azure for Operators thing is.
Yeah, no problem. So I'm the VP of 5G strategy for Azure. And really that means I lead up how we bring the Azure for Operators assets together. And really what Azure for Operators is there's sort of three pieces that came together to make up Azure for Operators. First of all, we launched something called Azure Private Edge Zones and Azure Edge Zones. So this was our ability to take compute right to the edge of the network and bring it together. So as you know today, to get from the mobile to the cloud or the connected device to the service, the cloud-based service, you end up transiting an operator's network, going out in the public internet, dropping off inside the Azure region. In this model, we actually move the compute resources either next to the customer in the case of an enterprise or at the edge of the cellular network in the case of more public services and sometimes small business. And so as a result, the compute is much closer. So Azure for Operators Edge Zones was the start of that. We then went and acquired two companies. We acquired Affirmed Networks and Metaswitch Networks. Affirmed Networks is a company that develops software for the packet core, which essentially is the brains that control how people get onto the network, the cellular network specifically. So in other words, the pieces that know who you are, what you're allowed to do, and where they should be sending your traffic. Metaswitch also has a packet core, but designed for much smaller footprint for the enterprise. But more importantly, they're a global leader in voice technology. So they actually offer the infrastructure that lets people do what's called voice over LTE or VoLTE, which is essentially your voice service on the cellular network. So between those two software assets along with the edge compute, we have a very, very well-rounded set of customers, right? We got more than 800 customers with Metaswitch, more than 115 customers with Affirmed. We have 16 different partnerships set up with telcos around the world on the Edge Zone partnerships, and bringing it all together really creates a very, very strong sort of operator or telco practice for us to sell Azure into that ecosystem.
Yeah, Shawn, I just wanted to maybe understand what the word operators meant in this space, right? Because I think it for me, it has a certain meaning. I know from the AKS world, we have this certain way we think about operators. Just explain to our listeners, what does operators mean specifically?
Well, I would have used telco because I'm a telco guy. I've actually been at Microsoft for just over a year now. I used to run product at Verizon for both wireless and wireline. And I came over because it was so exciting, the opportunity to transform the industry. And so typically when we refer to operators, we're trying to cover the category of your traditional telcos, which are folks that maybe sell wireline services or broadband services like cable operators, but more importantly also as well as the operators that provide, or the folks that traditionally called mobile carriers or cellular carriers. So essentially Azure for Operators covers all of those. It's a bit of a misnomer because the Azure for Operator strategy covers selling the operators, but it also talks about selling with the operators into the enterprise and into government. And in some cases, if you're using unlicensed spectrum, in theory, it's just putting together the network with the edge compute from an unlicensed perspective and taking that to them. So in other words, you may have heard something called CBRS recently. There was a lot of noise about it just because people spend so much money in the US around that. That's essentially where you can get access to spectrum that allows you to run cellular-like services without being a licensed carrier.
So, so what I hear you describing is both. I think you said it in terms of selling both to the people that operate these networks and these environments, and then the people that consume them. Obviously, I'm not an enterprise, but it sounds like theoretically, if I want to spend the money on it, I could go buy this hardware and I could set up my own localized network that runs on some wireless spectrum range.
Yes. So absolutely.
That's cool. I wanted that. I need a demo device. That's what I need.
Yeah. So let's be clear though, right? So a couple things, right? So yeah, Azure for Operators both sells to the carriers. In other words, we'd love to have them run that cellular network on Azure, right? Just like, much as enterprise IT has migrated off sort of that old vertical integrated stack to the cloud, so much so that that's not a new thing for a lot of people.
Yeah.
But in the operators world, they still run on, some vertical stacked applications sitting on special purpose hardware. And we'd like to see all that cloudify. And the move to software defined networking, the move to network function virtualization has made that possible. So that's awesome. And by the way, the typical operator operators are expected to spend $1 trillion over the next 10 years upgrading their 5G infrastructure. So it's a good place for us to go and spend some time with them. On the other side of the house, on the enterprise side, right, the IoT has never really truly achieved its full potential, right? People talk about it, but it's still too complicated. It's not resilient enough. It's not secure enough. It's not reliable enough. And we think by bringing together the cloud with the networks themselves and being able to present that to the end customer, that you can get that end-to-end sort of mobile to cloud or device to connected service story going together between the two of us. That's why it makes our partnership with the operator so strategic. But in your case in particular, there's certain countries, the United States with CBRS, Germany, Japan, Sweden, the UK, I think other countries like France and a few other ones are considering licensing out bands of spectrum that instead of having to go to the operator, that particular enterprises could set something up on their own. A big chunk of our strategy, of course, we've been partnering with the operators because so much of that spectrum is well defined. They've got tons of it. But there's also, just in our IoT strategy end to end, you're going to have the ability to do things like low powered WAN, Wi-Fi 6, and now we'll offer private 4G and 5G networking to go with that. So it just provides more options depending on what customer scenario you're trying to solve for.
I got a dumb question here. So, what in Microsoft's space, did we invent some API or something to make it easier for people to connect into Azure with these different networks? Because I assume, I mean, there's protocols and everything in place there already. So, what is the magic sauce that we've added with Azure for Operators that connects these much easier?
Well, prior to Azure, so the Azure for Operators initiative grew up underneath Yusuf Khalidi, who, as you may have known, up until recently ran Azure networking. And so he released a service, or that team released a service, Ross Ortega as well, called Azure Express Route, which was the operator's ability to tie directly into the network. Most recently, you saw the Teams organization and the people under Rajesh release ACS, Azure Communication Services. These are APIs where customers can call and run operator-like services over the network. They also provided direct routing where the operator could take their SIP trunking, which is basically the IP trunking they use to carry voice, and connect it up to our Teams offer. So there's all sorts of unique places we can connect together with the operator. Azure for Operators makes carriers have a unique requirement for how they process things. They're still very governed by physics. In other words, the network is all, we tend to think of cloud as a heavily centralized thing. Networking is, it only has value because it's as many places as you need it to be. You can't centralize all that. So our ability to take the cloud, as we did with the edge zone, and move instances closer to the customers where we add the secret sauce. And instead of relying on special purpose gear throughout the whole network, by providing a common orchestration, lifecycle management, security and policy, as well as DevOps environment across all of those, regardless of whether the compute's sitting in Azure public cloud or it's sitting at the edge of our network, right? As you know, there's 180 POPs that connect our networks into Azure. That's the Azure Edge Zones, or whether it's stuff we put at the edge of the network, like we do with the Edge Zones with Operator at AT&T, or whether it's at the customer's premise. Telco is complicated, I tell you. There's a lot of toys in between there. Having that all with one common control plane that's Azure-based makes it a tons easier for the operators to manage that environment. And because it's easier for the operators to manage that environment, they can in turn expose APIs to the enterprises that make that sort of seamless. So if you want to know nothing about networking, which is a lot of people, not me, obviously, I love this stuff, but not a lot of people do. It's odd. You can expose it up as API, so the programmer doesn't have to care again. Like they just kind of poof, it's not, but that's not possible without a lot of complicated technology underneath. So sometimes the simple things require some complications below the scenery, but this is what really the benefit for us, right? So the reason we care so much is not just because telcos are awesome people we want to spend a bunch of time with, which is true, but also because our ability to take our ecosystem, our developer ecosystem, raise the bar for IoT, and then bring the power of AI and ML into the real world becomes super exciting. And the reason I say that is really, if you think about it, when you've got that edge compute right, when you've got the compute right at the edge of the network, and you've got AI and ML running there, and it's connected direct into the network, you can now do things closer to near real time. So if you think about it today, you can go stick a wireless sensor on a gizmo and get, data off of it, and it goes to the cloud, and it can tell you what to do next time something happens, right? I can put a sensor on a piece of machinery. It can read the telemetry off the machinery, goes back into the cloud. We look at it and say, hey, this looks like it might break down in a few days. You should go do something. When you've got all of this where you've got the super low latency with 5G connected at the edge of the network, you can see things failing in real time, and in fact, use the power of AI and ML in the real world to go back and change things. So for example, if a robot arm is swinging at your head, it would be great if a high definition camera could spot that, send a signal to something and says, hey, does this look wrong? Yes, and go back and stop the arm before it connects with anyone, right? If you want to put people and machines together, stopping people from intersecting unexpectedly is a good thing, right? You don't want that going across the cloud. You don't want to have that problem in Tampa and make sure that you're going back to something in Seattle, right? That might be a little too close for comfort. This gives us the ability to solve for that. So it's super cool stuff, and it'll change not just the operators themselves, but it'll change the way we handle industrial automation. It'll change the way that smart vehicles talk to each other. It'll change the way that smart cities and smart buildings interact with people. Ideally, it'll become sort of the next generation content delivery, the dynamic insertion of content, the ability to make up images to overlay them in a mixed reality environment. When all that's done very close, you get an experience that's much better, right? Doesn't induce as much nausea. There's no lag. It's not all flat screens. I've actually experienced this directly. When you combine AI and ML at the edge of the network, close to the user as opposed to back in the cloud, that whole mixed reality experience becomes much more believable, much more tangible, much more real. So it's going to change tons of stuff, right? It's going to change the way both enterprises operate, but as well as some of the consumer experiences that we share over 5G.
I was going to ask you about gaming, because I keep seeing gaming in your background, and then I think you kind of described how it will enhance the experience. Can you go into more details on, in like layman terms of like, how does it make it faster? Because I'm connecting to Wi-Fi right now, and maybe like an Ethernet cable would make it faster. But then how does Azure for Operators help enhance that?
It's all physics.
It's all No, so if you think about it, if like one, you might be connected on Wi-Fi when you're sitting near a PC in your house, but when you're out wandering around with your handset or your tablet, maybe not so much horsepower there. The whole notion is that you can move both the content and potentially the game and the rendering commands to the edge of the network. And so as a result, you have a faster, shorter linkage back and forth to where those assets sit. You can deliver both the content, or if you want to dynamically change the content, you can do that at the edge of the network versus something sort of essentially backwards. So that any place where you don't have access to everything right there, say for example, you're not running your big huge PC, you're just carrying your little handset around, you've got a better chance to render more content. For things like AR and VR, where it's unlikely you're going to want to wear those monster helmet things. Like I love the HoloLens, but I don't know how often I would wear that if it was that heavy. You should be able to take this cost of the device down, because the device could become super lightweight, and then all of this stuff could run further back in the network in the cloud, so that you could have super lightweight, super decent battery usage type device. I mean, the same reason that people moved to the cloud in the first place was that you didn't want to have people didn't want to have servers locally, and they didn't want to have, they didn't have anything on the computer that they had to worry about. Well, this just moves everything not all the way back to the central cloud or the public cloud, but back to the edge of the network. So some cases it'll make more sense to do that. In some cases you'll just keep using cloud the way you do today. So, but it's all about where you render and where the content sits and can be delivered from.
Okay. I'm not gonna lie, this is definitely one of those subjects that is just over my head, because I think there's a lot of, it's weird how you'll learn about something in this space and you're just like, wow, there's a lot of like fundamental, probably primary things I would have to know before this could all like conceptually make sense to me. So let me kind of regurgitate back and make sure I understand. So when I think of like the 5G network, I think of like my phone provider, right? Like I think AT&T, I think my phone, I think, okay, this helps my phone be, more quick. When I think about like those edge zones, I think about like additional points of presence. So are we almost like allowing these partners to use our edge zones in order to like shorten the point of presence or the number of hops you'd have to get to their content? And then the 5G network itself, I know it's all about kind of the building of actual physical like cables and wiring, right? Like it doesn't just, when I think of the cloud, I think of like, oh, I'm hitting compute somewhere. When I think about the network, I'm thinking, okay, this packet has to actually travel from one piece of compute to another piece of compute through some mechanism. So are we making use of already existing infrastructure from that perspective? Or do we actually, I know we partnered to do like undersea cables and things like that, but I guess I'm just wondering like the 5G aspect plus the additional points of presence, like maybe where the responsibility lies. So I don't know if any of that even was relevant. I don't even know if
No, it's super relevant. That's actually, for somebody who said it wasn't a good question, that was an excellent question.
Those are the pieces
did
that
awesome.
I'm putting out of my mind, and maybe I'm not putting the puzzle all the way together.
No, you are 100%. So here's what we do. So Microsoft won. The magic what Microsoft does with the edge zones is just being able to get the right elements of the cloud into physically as close as it needs to be to the customer. And the customer want it because of latency, which is the speed at which you can respond. It could be for privacy reasons, right? A lot of times people don't want data going places that they don't have absolute control over. It could be for localization, sovereignty challenges. So that's the first part. The acquisitions Microsoft did of Affirmed and Metaswitch networks actually gives us the software that's used to run the network. So Affirmed and Metaswitch actually bring the software to the table. For example, when you pick up your 4G or your 5G phone and you make a phone call, they process that call. When you pick up your phone, period, the thing that makes sure you get a little signal and make sure that you go where you're allowed to go, that's what Affirm does. That's their packet core software. Without their software working, it doesn't work. And if you're on an AT&T 5G cell phone, you're on Affirm now. We actually, AT&T is a customer of Affirm's right now, so they're providing that 5G standalone service. So Microsoft has all those assets put together between the combination of the edge zones and the public cloud and our knowledge of that software. We can now, instead of them buying a box, like literally a physical box that's painted whatever color, the two vendors that are out there right now, or three if you count the one we're not allowed to use, which is a different podcast somewhere on the political spectrum. But they buy this, the lock and stock and barrel, this whole thing. 5 or 6 people show up with a loading dock, unload it, plug it in. It all uses proprietary interfaces. We're going to make it look like, and when we are in the process now and are doing it now, making it look like a typical cloud application. We'll give people access to cloud resources where they need it. We give them the software if they want our software. We also will get software from other people. That's part of the ecosystem development. Pop it on there, and then they'll be able to execute this work in the cloud versus having to do it using, something that looks like it's straight from 1996, which is where a lot of it is right now.
Okay.
So
Makes sense. Yeah. Okay. It wasn't that far off.
You nailed it. You thought right it through. So we're good. You should come do some of. Yeah, that was a pretty good question.
Yeah, I would actually recommend, by the way, anybody who is trying to sort of get their head wrapped around like what network is in the real world. There's a book called Tubes by Andrew Bloom, which is an excellent book. Talks about dragging the cables and these meetup locations. Even living in the networking space like I do, even I learned a bunch of stuff coming out of there about, again, the real world aspect. I think, Shawn, as I listened to you describe, pushing these things close to the edge, the analogy that jumps in my head that I want to validate is, originally one of the big complaints when people move things to the cloud is, hey, now my application or my database is on premises and my web server is in the cloud. Well, now it's slower, right? Because now they used to be in the same rack. Now they're in, two different, data centers basically. And we've done a bunch of work to, allow you to even put things in the same rack in Azure, so they're super low latency. What you're describing with Azure for Operators feels like that same sort of journey, but it's more for the for the connectivity side of things and pushing that compute sort of the reverse direction, right?
Yeah.
You're pushing it closer to somebody, but you don't want to get back all the complexity that you used to do. You want to push the simplicity of the cloud, but you want to push the processing to the edge. Is that the right way to think about this?
Yeah, 100%. That's where the value comes in, right? The magic here is Azure provides that commonality, like, the DevOps tools, the lifecycle management tools, Arc, for example, provides that commonality so that you can actually create this more complex environment. And the way you should look at it is no one will take an app that's running in a central cloud today and push it to the edge. That makes zero sense, right? These will be apps that can't run in the cloud today. And what you should think about this is it's, typical IT workloads, back office IT workloads, SAP, CRM, ERP, those kind of things. They work just fine, right, in the cloud. And they'll always be there. There's a whole bunch of systems called OT, or operational technology. That's the stuff that's used on the factory floor. That's the thing that's used in the retail, the retail wands. It's the stuff that that's the specialized IoT gear that the doctors wander around with. That stuff is all proprietary stack electronics today. And those are things that would benefit from. You can't integrate them, right? Like if you think about it, wouldn't it be cool if all this stuff just integrated? It was easy to manage. And by the way, people are worried. I mean, that's the kind of things people worry about getting hacked. Like, I get it. My Xbox got hacked. That of course never happens, but if it did, it would be terrible. But if my insulin pump got hacked, a little more serious, right? So that's why you want that common security layer. That's there's some value in having all that stuff, connected, and you be able to feed this to back to some place you control and having it all interacting with each other. But that doesn't happen today because that's not available. So there's a ton of advance to be made by distributing this compute, by connecting it direct into the network and really giving people a way to supersize automation, which is something you can't do today. So really the use cases, don't think, oh my God, everyone's gonna move things to the edge now. That makes no sense. You're right, it doesn't. They won't. It's, other things, another example in public sector, AI and ML that runs locally. Like if you have a high def camera that's running to a machine learning engine at the edge of the network, if the inference engine is sitting there making decisions, that's fine. If you start collecting that data, it starts to get really creepy. So the idea that you can sort of do some of the AI and ML at the edge helps address some of those challenges, right, as well. So there's all sorts of scenarios that come up here. If you think about it, high def cameras, if you're starting to think about production quality assurance or medical imaging, you want to capture as much visual fidelity as you can, but you got about 1,000 to 1 image to data, image to signal compression for video at the edge. If you've got that edge compute, you shrink it all down. You don't have to buy pipes the size, you don't have to buy 2 undersea cables to go back to the cloud to get that to work, which is worth a fortune, right? If you had to do that for 30 cameras in a retail store, it'd be too expensive. So this kind of helps you do that balance or that trade-off. So will we talk about latency, because that's the physical distance a lot, the security aspect of it, as well as the ability to process data at the edge, all becomes super important, and it'll unleash a whole. My real belief here is a big reason I came to Microsoft was a belief that this was a chance to fundamentally change not just the telco industry, which is passingly interesting, but industry in general, and the experience that people have is going to change here, and that's what makes it so cool.
Shawn, you mentioned Arc, and I was about to say that this sounds a lot like the way Arc solves the problem of, running information locally and then just having that common pane of glass that they can have. So is that another way to think about it from an operator perspective?
Absolutely. A big chunk of the strategy will be taking Arc. There'll probably be an industry extension to it and overlaying that across all of it. You 100% get it. That's exactly what we're planning to do.
Awesome. This is great. I can't wait to be able to tell somebody, hey, and I'm running my phone and my my local connectivity on
Exactly.
stuff that I support. Well,
Yeah.
I don't know if I actually am ready for that. But yeah, no, this is great, Shawn. Appreciate you coming on. Any last thoughts you want to leave the audience with?
Now, as I said, for everybody who's here at Microsoft, I'm relatively new. I hope you're as excited as I am about all the cool things Microsoft's engaged in. As I'm going through this Azure for Operators effort, sure, I'm touching a lot of the techno network stuff that may not be as exciting to people, but I get to see the change that Microsoft is making in terms of agriculture and manufacturing and healthcare, and it's absolutely inspiring. There's just a lot of smart people at Microsoft doing many cool things to make the world better, and the chance, obviously for me, this is a dream job because I get to take all that super cool stuff, bring it to an industry that you might not describe as the most exciting on the planet, and really change things. And that wouldn't happen without the culture and the team at Microsoft. So, big thank you to everybody who's engaged in that, because this is fun, but I'm not, there's a ton of people out here doing really interesting stuff to make that happen. So it's a great place to be.
Yeah, it takes a not just a village, but a huge village,
Yeah.
right, to do this. So no, this is great. Thank you again for coming in. We will make sure to share some of the links, for some of the announcements we talked about with our audience, and we'll have to get you back in a year or two, and you can tell us about some of the cool things that you guys have seen people invent, right, with this new technology at this point. Okay, sounds great. Thanks, folks.
Thanks very much. Bye now.
Appreciate it.
Thank you. Take care.
Ciao.